Intro to Electronics and Diodes. In this presentation, we're going to talk about, well, an introduction to electronics and diodes. Let's get going with the introduction. Most electronic devices are manufactured from silicon carbide. The material is known as a semiconductor. Depending on an external voltage or current applied, semiconductors will either block or conduct electrical current. During the semiconductor manufacturing stage, there are two unique types of silicon produced through a process called doping. This creates P and N-type silicon. P-type has very few free electrons and often referred to as the material with additional holes in it. And N-type has many free electrons. When P and N-type silicon contact one another, a depletion region is created called a P-N junction. And we can see that in the middle right here. Now, depending on the polarity or the current or the voltage applied to the P-N junction, it will block or allow current flow through with no physically moving parts. Most electronic devices are made from P and N-type silicon. Although the same raw materials are used, each type of electronic device has unique operational characteristics. These unique characteristics are due to differences in the doping of the silicon, the quantity of the silicon, the relative location of silicon, layers of silicon, and finally additional materials that may be used. Along the bottom you can see I've got 5 different very common electronic devices. Each one has a different arrangement of P and N-type material, but that's it. P and N-type, different layers, different combinations of P here and N there, multiple layers. Each one is a little bit different. The diode is the most basic electronic device with a single P-N junction between the P and the N-type silicon. The ends of a diode are labeled anode and cathode. This identifies the P and the N silicon on the component. When connected into a circuit, a diode will allow current flow under very specific conditions. The cathode must be connected to a negative polarity of an electrical source. The voltage across the diode must be at least 0.7 volts, and I appreciate this will change dependent on the type of diode used. Some of them are as low as 0.3, others are as high as 1 volt. For this presentation, I'm just going to refer to 0.7. It is easiest to consider a diode as a polarity-sensitive switch when we're discussing it, because either a diode is fully closed or fully open in the same way that a switch is. When a diode is positioned with the cathode connected to the negative side of a source, it is said to be forward biased. This means, dependent on the voltage, it is capable of conducting current. Here we have a forward bias conducting diode in a DC circuit, and we see there's an 11.2 ohm resistor there. There must always be a load or a resistor to limit the current through the diode, because the diode is really just a switch. And if the switch is placed across a source without any sort of appreciable ohmic value, it will cause a short circuit and destroy the diode. Now, in conducting, the circuit is a complete series path. This means source voltage will split across both the load and the diode. Unlike a standard switch, the voltage drop of 0.7 will be across the diode. So we can see here on a 10 volt source, 9.3 is across the 11.2 ohm resistor. The current is then calculated using Ohm's law through the load and the voltage across it. So 9.3 divided by 11.2 gives me 0.83 amps that would flow throughout the circuit. When reverse biased, it is considered a blocking diode, and the diode will not conduct current when the cathode is connected to the positive side of the source. Since the diode acts as an open switch, in a series circuit the full source voltage will be dropped across it. So we can see here 10 volts across the diode, no volts dropped across resistance or the load of the circuit. Now there will be a very small value of current which flows when a diode is reverse biased, and this is called leakage current. If we were to increase the voltage while the diode is reverse biased, we will eventually reach a point of maximum blocking. If this value is exceeded, the diode will be destroyed by current flow through it. This voltage rating is known as the peak inverse voltage, and the diode will be damaged and destroyed from that current. The overall characteristics of a diode are sometimes shown on an IV curve. We can see here voltage and then here current. As we increase the voltage across the diode up to approximately 0.7 volts, if it's forward biased, the current through it will increase. Just like a switch, the current would increase when the switch is closed. If instead we go into the reverse bias polarity down here, a very small amount of current will flow, and that represents a leakage current. If we get to this point called the breakdown voltage or avalanche, eventually we will then damage the diode because the current flowing through it in the reverse direction is not what it's designed for. A diode can be tested with a basic ohmic function on a digital multimeter or analog multimeter by placing the positive and negative leads, the positive to the cathode, negative to the anode. We should confirm that the diode is blocking because we've reverse biased it. And that's because there is a battery inside the multimeter. If I instead reverse the connections, I should then see continuity or a closed connection of very low ohmic value. There are many different applications for diodes, one of which is suppression of an inductive DC voltage kick. This is a battery that's connected with a switch to the coil of a relay, and the coil is inductive. What's important about that is that when I close the switch, the coil energizes, a small amount of current flows, and the relay contact closes. This is an inductive DC current. And when I open the switch, what will happen is a rapidly collapsing magnetic field in the coil, which will then result in a brief inductive kick of voltage. Now, this inductive kick of voltage could be destructive to other apparatus in the circuit, especially electronic controls or programmable logic controllers that might be supplying it, as opposed to just a basic battery. So, to prevent this from happening, we connect a diode into the circuit. And it's a freewheeling or blocking or suppressing diode, is just different names that are used for this application. So we close the switch and it has no effect on the coil. There's still a little bit of current that flows, the relay contact closes, and the diode is reverse biased. The reason that this works is that the brief inductive kick that is generated during the collapsing magnetic field will cause a source voltage to be set up that is opposite or opposing to the initial source that created it. That's Lenz's law. So during the inductive kick, the diode will be forward biased, giving a path of discharge for that voltage, not destroying the diode and not affecting any other portion of the circuit. Another very common application for a diode is to do rectification. And rectification is the process of taking AC voltage and generating DC voltage simply because a diode will only conduct when in forward biased mode. Therefore, in an AC sine wave, it's only going to be conducting for half the cycle. Diodes come in many different shapes and sizes. The larger the diode, the higher current it is able to carry. Axial type are the very small ones that we see connected into circuit boards, all the way up to a puck type, which is very large, meant for very high values of current. Sometimes they're individual like this. There's a stud mount, and then a stud mount connected to a heat sink, and finally a puck type mounted to a heat sink, and that just disperses the heat so that the operational temperature of the unit can remain within its rated value. All diodes will come with the ratings from the manufacturer, and this will provide detail on the maximum current, power, voltage, inverse voltage, and temperature of the unit. As a closing summary, a diode, when connected and forward biased and 0.7 volts across, it will conduct current. Current through the diode is determined by the load and is either on or off. Polarity of source across the diode must have negative on the cathode, and it's usually connected in series with loads or devices.